Dear students, in last class I have explained an important concept based on the electric dipole. What is an electric dipole? So this question has appeared twice in the examination, and the answer that you need to write is: an electric dipole is a pair of equal and unlike point charges separated by a small distance. An electric dipole is a pair of equal and unlike point charges. This is how we represent. So this is an electric dipole. So there is a pair of equal. So one is Q, again other has to be Q, but it is equal in magnitude, but it has to be an unlike. So if it is minus Q, the other has to be plus Q. So this is how we write. Separated by a small distance, which is 2a, which is called electric dipole length. And strength of an electric dipole to produce an electric field depends on electric dipole moment, which is given by P is equal to Q into 2a, having SI unit coulomb meter. It's a vector quantity. It's always directed from negative charge towards the positive charge. Negative to positive. So that's the direction of electric dipole moment. But the question that has appeared is, what is an electric dipole? The next question: derive the expression for electric field at a point on the axis of an electric dipole. So again, you can see this question has appeared 3 times in the examination, and I have yesterday derived expression based on this. What is the expression that we derived? Expression for electric field at a point on the axis is E is equal to 1 by 4 pi epsilon naught 2 pr by r square minus a square the whole square. And for short electric dipole, E is equal to 1 by 4 pi epsilon naught 2p by r cube. So all this we have already learnt. So I just wanted to tell you that this particular derivation is important for 5 marks. It's a repeatedly asked question. So what we are going to analyze today. So another important question, again another derivation. This time the derivation is to find the expression for electric field at a point on the perpendicular bisector, because around the electric dipole there is a field all over, not just on the axis of the dipole, correct? There is a field everywhere, correct? So now at a point on the perpendicular bisector, perpendicular bisector means the line passing through the center and perpendicular to the axis, that is the perpendicular bisector, okay? So again this question has appeared 3 times. It has appeared even in the supplementary examination, which was held in the month of September this year, okay? So again important derivation. So let's concentrate on this particular derivation. So easy and simple, but you need to follow all the steps very clearly, okay? So let me draw the diagram here. So first I am going to draw an electric dipole, and keep in mind, whenever you draw an electric dipole, always write the center of negative charge first. For no reason, understood, because it's given in a similar manner in our notes, so that you don't get confused. Always draw negative charge first, and then the positive charge, that is center of negative charge, center of positive charge, and O is the center of AB. So what is the value of OA? It is semi-dipole length, that small letter A. What's OB? Again semi-dipole length, which is A. Now our aim is to find the expression for electric field at a point P at a distance r from the center of the dipole. So we have to derive an expression for electric field at that point P. So that's what the aim of the derivation. Now the method to find the resultant electric field remains same. That is, first find the field at point P due to plus q, then find the field at the same point due to minus q, and then find the resultant. But it's not that easy as it looks, so you will come to know why and how. So let's first decide what is the distance between the charge and the point which is here, because we want that distance to find the electric field. This is R, this is A. So according to the Pythagoras theorem, this particular distance is nothing but square root of R square plus A square. Similarly, even this is also the same, because this is R, this is A, so this will be root of R square plus A square. We need the distance, so that's why we are keeping it ready. So let us first find the field at P now due to the positive charge. So I'm going to write that here, which is E plus Q, field produced due to the positive charge, is equal to constant 1 by 4 pi epsilon naught. After that, charge, which is Q, divided by square of the distance, because that is what the formula for electric field, right? E is equal to 1 by 4 pi epsilon naught Q by R square. But here that R represents this distance, the square of the distance. But it is already root, correct? No? So what is the square root of R square plus A square, the whole square, which is nothing but only R square plus A square. Square root of R square plus A square, the whole square, correct? The square and this root will get cancelled, giving R square plus A square only. Right. Now what is the direction of that particular field at that point? So you place a plus 1 coulomb to understand the direction. This is a positive charge. This is also a positive charge. It's a repelled in this direction like this. So that will be E plus Q. So that is BP extended, correct? No? So it's along BP produced, we write. Next, find the field at the same point, but this time due to the negative charge, which is E minus Q, is equal to 1 by 4 pi epsilon naught. Magnitude of the charge we consider, we don't consider the negative sign, by square of the distance. Square of the distance means the square of this, which is the same thing again, which is R square plus A square. What is the direction of this field now? So this is a negative charge, this is a positive charge. So this positive charge is attracted towards it. So therefore the direction of the field will be like this. So that will be E minus Q. E minus Q. So that will be along PA. Along PA. So now we have two vectors. One vector is here. The other vector is here. So we have to find the resultant. To find the resultant, we construct a parallelogram like this. And then we get the resultant here. This will be the resultant, which is E. Now to find that resultant, I'm going to use resolution of the vectors, splitting of a vector into two components. So for which I'm going to consider this angle to be equal to theta. And we can find that angle because we know all the three sides, A, R and root of R square plus A square. With the help of trigonometric function, we can find that angle. And it's a isosceles triangle because two sides are equal. Therefore, if this angle is theta, then even this angle is also theta. Correct? Now say this. This resultant and this AB here, they are parallel. If these are parallel, then this angle theta has to be equal to this corresponding angle. If this angle is a theta here, then this angle also has to be equal to theta. That's alternating angle. And once I come to know those angles, it's very easy to resolve the vectors. How to resolve? Now check this. So this is E plus Q, which is here, okay? you split into components. So theta is here, therefore the component along this direction is E plus Q cos theta. That is because theta is here, so this component is E plus Q cos theta, and the other component will get up here vertical, which is E minus Q sin theta. Not minus Q, E plus Q only. So hope you understood. This E plus Q we resolve into components. One E plus Q cos theta and E plus Q sin theta. Similarly, resolve this vector here, which is here, E minus Q. E minus Q, theta is here, so therefore along this direction, one more vector like this. So that will be E minus Q cos theta, and then the other vector, other component will get downward here like this, which is E minus Q sin theta. So one vector is splitted into two rectangular components. E minus Q cos theta, E minus Q sin theta. E plus Q sin theta, E plus Q cos theta. Clear? Okay. Now from this, we find that E plus Q is equal to E minus Q. See, look at the equation. E plus Q and E minus Q. They are the same, they have the same magnitude. So that is the reason why E plus Q sin theta and E minus Q sin theta, they make an angle of 180 degree. So when theta is 180 degree, the resultant is a P minus Q. Resultant is always the difference in the vector. And these are equal because E plus Q and E minus Q are equal. Sin theta is the same. So therefore now if I use this formula for theta 180 degree, here R becomes 0. So resultant of these two vector becomes 0. They get cancel each other. But what about here? These two vectors, they are along the same direction. That is, theta is 0 degree between them. When theta is 0 degree, what is the resultant? Resultant is P plus Q. Sum of the two vectors. So now, therefore the resultant E is equal to P plus Q. So we have to add them. So what do we get? E minus Q cos theta plus E plus Q cos theta. But E minus Q and E plus Q are same, right? So therefore this term and this term are same. So that's why it will be double. Double E plus Q cos theta or double E minus Q cos theta, because both are equal. This is equal to this. So that is equal to 2. What is E plus Q? E plus Q is here. 1 by 4 pi epsilon naught Q by R square plus A square. What is cos theta? We can find cos theta very easily from the diagram. See, theta is here. This is the opposite side. This is the adjacent and this is the hypotenuse. So what is cos theta? Cos theta is A by root of R square plus A square. So cos theta is A divided by R square plus A square to the power half. That is nothing but square root only, correct? So that's it. We are almost there with the final expression. So therefore now E is equal to 1 by 4 pi epsilon naught. See the numerator, 2 Q into A. Dipole moment is nothing but Q into 2A, right? So therefore that 2Q into A is nothing but dipole moment. So which is a P. So that's why P divided by, here the power is 1, here the power is half. Add them, 1 plus half is 3 by 2. So therefore divide by R square plus A square to the power 3 by 2. So that is the final expression for electric field at a point on the axis, not the axis, at a point on the perpendicular bisector. This is called perpendicular bisector of a dipole. How to write this in vector form? If you see the diagram, Dipole moment is like this, from minus q to plus q. This is the direction of the dipole moment. But the resultant electric field is exactly opposite. See, this and this are opposite. So that's why when we write in vector form, we write like this: vector E is equal to 1 by 4 pi epsilon naught p by r square plus a square to the power 3 by 2, and then we write minus p cap. Minus indicates that electric field and the dipole moment, they are in opposite direction. I hope you have understood this derivation, repeatedly asked derivation. And one more last point I would like to mention, that is, suppose if it is a short electric dipole. If it is a short electric dipole. So when do we say that an electric dipole is short? When this perpendicular distance, when r is much greater than a. So that implies r square is still greater than a square. Only then we call it as a short electric dipole. When r is much greater than a, then we can neglect a square in the denominator. So what do we get here is E is equal to 1 by 4 pi epsilon naught p by, neglect a square, and what we get is r square to the power 3 by 2. R square to the power 3 by 2. This 2 will get cancelled, and what you get is r cube. So this is the expression for electric field at a point on the perpendicular bisector of a short electric dipole. How to write this in vector form? Vector E is equal to 1 by 4 pi epsilon naught p by r cube into minus p cap. So what is the expression do we get at a point on the axial line, on the axis, for short electric dipole? The equation that we get, this is at a point on the equatorial line, or we call perpendicular bisector, correct? At a point on the axial line, the equation that we get is E is equal to 1 by 4 pi epsilon naught 2p by r cube. Here we get p by r cube, there we get 2p by r cube. Therefore, if you consider this at a point on the axis, and this is on the perpendicular bisector, and then if you find the ratio of it, divide A by E perpendicular. That perpendicular line is also called as the equatorial line. Okay, you can even write E suffix E. Then the ratio 1 by 4 pi epsilon naught will get cancelled, r cube will get cancelled, p will get cancelled. So what remains is only that 2. So therefore the ratio is a 2:1. So what is this new expression? This is the expression for ratio of the electric field at a point on the axial line to that of the equatorial line of a short electric dipole. So hope the derivations are clear. So we make use of the resolution of the vectors, and that's how this particular equation is derived. So I'm going to give the comparative equations of electric field due to an electric dipole. So at a point on the axis and at a point on the perpendicular bisector, electric field at a point on the axial line, general formula E is equal to 1 by 4 pi epsilon naught 2pr by r square minus a square the whole square. At a point on the perpendicular bisector, which is also called as equatorial line, okay, equator. So 1 by 4 pi epsilon naught, it's p by r square plus a square to the power 3 by 2. So this is what we derived in today's class. If you want to write in vector form, vector E is equal to 1 by 4 pi epsilon naught 2pr. Write the same, r square minus a square the whole square, and then introduce a unit vector. Here vector E is equal to 1 by 4 pi epsilon naught p by r square plus a square to to the power 3 by 2, and then you have to introduce a negative vector because electric field is in a direction opposite to that of the electric dipole moment. That's why it is minus. Then due to short electric dipole, E is equal to 1 by 4 pi epsilon naught. It's a 2p by r cube. Here E is equal to 1 by 4 pi epsilon naught p by r cube. Same thing in vector form, vector E is equal to 1 by 4 pi epsilon naught 2p by r cube, and then introduce unit vector, and then here vector E is equal to 1 by 4 pi epsilon naught p by r cube, and then minus p cap. So these are the comparative equations in the two cases. So both derivations are very important for 5 marks. I'm going to continue with more regarding the electric dipole in the next class. Thank you.